And the big deal for the test is, it's already circled, but I'll highlight it, mixed integration. So up until now, every day like had its own topic, right? Like today it's power rule, today it's e to the x, the next day it's inverse derivatives or inverse sine functions, inverse trig functions. And today we just like dump them all in and scramble them up. And so we've got to know all of them well enough to recognize which one it is, and then also to actually do the problem. And so that's what makes this worksheet and the test a little bit trickier. So looking at number 2, I see 5 to something and an x out front. But if I let u be the 3x squared, du is 6x. And again, part of picking u is thinking ahead a step to know what du is, to know if it's a good pick for you. Right? So you don't know that u is a good pick until you see what du is. Right? But you don't know what du is until you pick u. So if you can think ahead a little bit, you can go quicker. If not, and I'll do it a couple times later, like on purpose, like you pick the wrong u, it doesn't work, you go back, you pick something else. That's part of the process. That's okay. But I'm pretty sure I got this one right because there's an x. So all I need is a 6. You can spawn any constant you like in there, but do not stick x's in there. You can't be like, oh, I need an x, let me put an x inside and an x outside. You can't do that. So numbers fine, constants or variables don't do that. Okay, so 1/6, the 6x and the dx, that makes du, and then I've got 5 to the u. Ooh, 5 to the u, that's, I know it's 5 to the u, because it's sort of like e to the x, but there's a 5 there, so what else do I need? Because it's a 5 and not an e. Yeah. Natural log of 5 in the top or in the bottom? Am I multiplying by natural log of 5 or dividing by natural log of 5? Dividing. If I was taking a derivative, I would be multiplying by natural log 5, but I'm taking an antiderivative, so I want to divide by natural log of 5. Don't forget the plus c. Of course, that's only an issue on the free response questions, and I think 2 of the 4 are have limits, so you don't have to even worry about the plus c. So it only occurs a couple of times, but don't forget about that. That is a safe stop because I've defined what u is. On the multiple choice part of the test, that 3x squared would be plugged back in there. So either one of those is fine, but multiple choice is going to replace the u. On the free response, you're welcome to leave the u. Save yourself a little bit of a step. All right, number 5. Again, sort of recognizing big picture what's going on and then picking u and du, and all of that sort of goes together. So thoughts on what u should be? Let's do square root of x because then it's e to the u, and hopefully this is an e to the u problem. I don't really like square roots, so I'm going to just rewrite that as x to the 1/2. So 1/2 x to the negative 1/2, which is 1 over 2 times the square root of x. And again, you don't have to keep hopping back and forth between the exponent form, the power form, and the root form. But powers are more convenient for derivatives. Roots are how the problem started. So you got to be able to go back and forth whether you write it out or not. Oops, need a dx on that. So this is good. So this is almost du. If I put a 2 in the bottom, which means I need a 2 in the top. So a 2 out front, antiderivative of e to the u du. That's always the name of the game in u substitution. If you pick it right, you end up with an easy integration. limits. We didn't have to do that last time because we didn't have limits. So last time we had to remember the plus c. This time I need to consider those limits. And by consider, I mean change them. If x equals 4, then u equals
2.
The square root of 4, which would be 2. And if x equals 1, then the square root of 1 is 1. So we go from 1 to 2. Obviously, you don't have to highlight all of that. You really don't even have to write down the work to get there. I'm showing my work, but a lot of people don't put that. They just change the limits and they're fine. And that's fine. Just, again, show the work that you need to show to get you through the problem. Antiderivative e to the u is e to the u. We're still at 2 from 1 to 2. That's not a safe stop, right? Because I got to plug in 2 and 1. So e squared minus e to the first, or e. Again, stop me if we need to go further somewhere. What do we think about number 8? This is the problem with integration. There's like 14 rules. You got to have them all kind of at the top of your head so that you recognize what to do on each problem. Let's divide. So I can do some algebra first on this one. So x squared over x is x minus 1 over x. So after we divide, this is pretty easy. Antiderivative of x is x squared over 2. Antiderivative of 1 over x is natural log of x. From 1 to e. Since the safe stop approaching soon, e squared over 2 minus natural log of e. Be careful with like parentheses and brackets and making sure you subtract the right thing. All right, so plug in the top, minus plug in the bottom, but top minus bottom, I'd put them both in parentheses. Be clear. 1/2 minus natural log of 1. And there's a lot of cleanup that could be done there, but that is a safe stop. You could be done there. What's the natural log of 1? Said the answer. Natural log of e is 1. What's the natural log of 1? 0. So if I clean this all up, I'd have e squared over 2 minus 1 minus 1/2. I could get real fancy and make it e squared minus 3 all over 2. Right? Yeah, because 1 and 1/2 would be 1 and 1/2. They're both over 2. So there's my fancied up multiple choice answer. There's my free response, leave me alone, I don't want to do algebra answer. Which there's nothing wrong with that, right? Like, if given the chance, you should leave your answer like that, just in case you mess something up with signs or common denominators or whatever. Like, don't even risk it. Leave it like that. Speaking of dividing, before we go on, number 6, obviously I'll work that in a different period, but what would we do on number 6? You'd have to long divide. So that would be a yucky problem. I'd have to long divide and then take my answer, and the biggest mistake on number 6 is not that people forget to long divide. They long divide and then they box that up as their answer. Like, no, long divide and then don't forget the antiderivative part. So number 6 would be a lengthy problem. Number 11. Integral of absolute value. We don't know an integral for absolute value. So how do I work this problem? Speaking of the 14 things that have to be at the top of your brain to do antiderivatives. What else does that symbol mean? It means antiderivative, which means underivative. It's like go backwards if you have an equation. But if you have a graph, it means area under the curve. And for an absolute value, it's like, oh, I'd much rather just do area, because that's just going to be triangles. So let's graph it and then do area from 1 to 4. Let's see, x minus 3 moves it to the right 3. And then it's just that the absolute value v thing. And I'm going from 1 to 4. So it's just going to be the area of those two triangles. So 1/2 base times height plus 1/2 base times height. And again, safe stop, right? That's the answer. No need to go any further. Multiple choice. Let's see, half of 4 is 2, half of 1 is a half. So 5 halves is your prettied up multiple choice answer, but don't go there unless you have to. It was easy when they were in rows and columns of 3, so I knew which one was next. 11 plus 3 is 14. Okay. Oh, by the way, I should have said this at the start. I did the key yesterday, and as I do the key, I usually have a piece of paper next to me and kind of take notes of what I think are the trickiest problems to either put them on warm-ups or call your attention to them or something. And so I got through with those. And then I looked over the review. I'm like, oh, they're all in the review, so I don't feel bad. So yeah, there's some goofy ones, but they're all in the review. Speaking of goofy ones, number 14. If the integral from 0 to 8 f of u du is 6, and the integral from 1 to 3, well, I don't know, but what do you think we do first on 14? Especially if I want it to look like this. Let's do some u substitution. I'm thinking these things are related. So if u is x squared minus 1, then I'd have f of u. du is 2x dx. Okay, that explains the x there. Do need a 1/2 out front. So 1/2. Antiderivative. Careful, it's not 1 to 3 anymore. F of u du. So I'm getting close to this. I'm guessing the 1 and the 3 turn into 0 and 8. That way this thing is helpful. But till I do it for sure, I don't know. Alright, if x equals 3, then u equals 9 minus 1 is 8. And for the bottom one, if x equals 1, 1 minus 1 is 0. So the bottom limit is 0. And that's kind of what I expected to happen. Otherwise, this piece of information wouldn't have been any good. So that's 6. So half of 6 is 3. I'd bet anything the multiple choice answers are 3, 6, 12, and who knows. So it's the big part of that was that chain rule where that 2 came from, because that 2 led to the 1/2, which led to this being 3. 15, you might can tell is pretty similar. You're going to let u be x minus 2 and then kind of go from there. Number 17. By the way, 13 and 16, similar u substitution stuff. Obviously, maybe not obviously, this one's an area problem because it gives you a picture and tells you areas. 16 is a table problem, so after you do it, you'll use the table to evaluate things. But both of those are in the first period video. 17. U is something. What do you think? Why cosine? Why not sine? Like, right? Because, I mean, the derivative of one is the other, so in some sense it's like, well, I can make u and du show up. You're right to pick cosine. But what was your reason? Because it's in the square root. Okay, that works. So that should simplify the square root. Du then is negative sine of x dx. So not perfect, but not far off. I can fix it with the negative. So I don't like roots though, because that's a prime spot to mess something up. I'm going to rewrite that as a power, and that just makes it a whole lot easier. There's not really a root rule. There's a power rule. So increase the power by 1, divide by the new power, plus c, because there weren't limits to even worry about. I'd said what u is, so I can leave it like this and be done. Again, most of the test is multiple choice, so we'll sort of force you into. That's probably what the multiple choice answer would look like. They'd put it back as a root, and they put cosine back in for you. But on your own, this is a perfectly good free response answer. Lots of u substitution going on. Number 20. Another example of you got to have all the derivatives in your head so that you can recognize u and du. You need to have all the integral rules in your head so you can kind of see where this is headed. And if you can hold like all of that in your head at once, then what do you think would be a good pick for you? What'd you say? Secant. Because what's the derivative of secant? Secant tangent. You're like, okay, I'm well on my way here. I got the entire top taken care of. That's du. And the bottom, now I've got 4 minus u squared. I'll need to fix the limits as well in a minute. 4 minus u squared. Oh, this looks like one of those inverse trig functions. But which one is it?
Sine.
Arcsine. Arctangent is the one that doesn't have a square root. Arcsine has a square root, and the argument comes second. Arcsecant is the one that has the x out front, and this order is reversed. So I'm pretty sure I'm headed toward arcsine. So a is 2. I've already said what u is. Let's go ahead and fix the limits. So let's see. If I plug in pi over 4, I need the secant of pi over 4. Thank you. Secant of pi over 4. Let's see. The cosine of pi over 4 is root 2 over 2. And if I flip that over, I get square root of 2. So square root of 2 in the top. The secant of 0, again, nobody thinks secant. Everybody thinks cosine. Cosine of 0 is 1. If I flip that over, I get 1. So now I've got my new limits to deal with. Okay, we said this was arcsine, u over a. And I have u's, so I'm not going to put secant of x back in there. I'm going to leave it as u over, I'm going to put the 2 in there. From 1 to square root of 2. Yeah, I'm just rechecking. Yeah, I think I'm on the right path here. Arctangent has the 1 over a out front. It's the only one that has the 1 over a out front, so I'm still good here. So arcsine of root 2 over 2 minus arcsine of 1 over 2. And that is a safe stop, right? Because that's not calculus. That's pre-cal. Now, multiple choice, we're going to assume you know. Let's see, the sine is root 2 over 2 at pi over 4. And the sine is a half. That would be at pi over 6. So that's a safe stop. That's a safe stop. And if we really wanted to get fancy, we could go common denominators here. 3/12 and 2/12 is 1/12. Again, I just keep showing both because if it's on the free response, then please stop there. Like, don't risk it. Even if you know you could get there, like, don't risk making a dumb mistake. When you can safe stop, safe stop. But obviously, multiple choice, usually we require you to go a little bit further. All right, 23. 23 looks, I feel like 23 kind of looks like 20. I'm thinking arc sine when I'm looking at 23. Which means this needs to be a, would be square root of 3. And what would u need to be to make that u squared? What squared would get me to 16x squared? 4x. And du is 4dx, so I got a 4 I need to throw in there. I usually just kick this guy out and put the 4 in on my own. Some people would just multiply by 2 to get to 4, but I'm just going to put the 4 in there. I think that's easier. And then I'll deal with the 2/4 out front. So now I've got du over square root of a squared minus u squared. That's arc sine. So 1/2 arc sine u over a plus c. And double checking, I said what u is, I said what a is, so I'm okay with this as an answer. Again, the trick is you start going fast through these and you look at it and you're like, oh, I know what a is, I'm fine with that. And then you put a as your answer, but you hadn't said what it is. I'll take off a point. Okay. Next one is 26, but let's do kind of all three of these together. 25, 26, 27. Tangent, or excuse me, antiderivative of tangent. This is one that I'm supposed to have memorized, but I don't have memorized because I always know I can figure it out. Maybe I should just eventually memorize the thing. I know it's natural log, but I can't ever remember if it's natural log of what, and it's a plus or minus. So I need a negative sign in there. And it would be natural log of u, which is cosine. So negative natural log of cosine of x. In theory, I have that memorized, but I also know that that one's an easy one for me to figure out. So I've never committed that one to memory because I just can figure it out pretty quick. There is one trick that you will see on the test. Like this is the preferred answer in my mind. But if you want to get tricky, you can take that negative and make it an exponent, which flips over the cosine. And what's the flip of cosine? Happens when you flip cosine over? Sounds like you get secant.
How would you do that when on the test? It seems like torture.
It does. It does seem like torture. So yes, you will see that on the test. Again, it's working the key last night. I wrote this down as an answer, started looking at my answer choices, and I'm like, wait a minute, did I do something wrong? Did I forget the negative? And then I saw that answer, I'm like, oh yeah, that's... So again, hopefully with the answer choices there, your brain can make the leap from here to here. And if the answer choices weren't there, you wouldn't make that leap anyway, which is fine. 26, that's our regularly scheduled problem. That one, that's the weird one. If you want to get there the long way, you have to multiply top and bottom by secant plus tangent, I think. Yuck. That one you should just memorize. It's the natural log of secant plus tangent. You could check that by taking the derivative, but it'd be kind of a long way around. So those are the ones you just have to know. Okay, 27 looks bad, but what's the relationship between the derivative of tangent and the derivative of cotangent? Do you remember? Or the integral, either one. All the trig functions are change the sign and change the cos and not cos. So if I've got the antiderivative of tangent right there, then I'll make it positive and change the cosine to a sine. And so there's my answer. Again, I don't have antiderivative of cotangent memorized directly. I know it's I don't even want to try to write it down. Change the sign, change the cos and not cos for tangent, and then there's my answer. Okay, but really you should have at least tangent and secant memorized. The others you can figure out. 26, 29. Derivative of arctan. We haven't seen that one yet. We've had arcsine several times. Arctan, that's the one that's 1 over x squared plus 1, or 1 plus x squared. Order doesn't matter because we're adding. For those of you that like to emphasize you're thinking about the chain rule, you could put times 1 out there. And then square roots. Again, we don't do roots, we do powers. So I'm going to change it to x to the 1/2. 1/2 times 2 goes away, x to the negative 1/2. So let's see here. Boy, some of these answers are crazy. Square root, that looks like sine, arcsine rather than arctangent. Same thing there. Okay, D, we're getting closer, but that's no, that 4 and cube, I don't know what's going on there. Yeah, it's E. 1 over 1 plus x squared, and then x to the negative 1/2, that's the same thing as square root in the bottom. Now you know why we spend such a long time in algebra 1 and 2 and pre-cal with roots and powers going back and forth. 32. The derivative at 1/2. The derivative of arc cotangent. Arc cotangent? Come on. Okay, but the derivative of arc cotangent is almost the same as the derivative of arc tangent, except that it's a minus in front. So it's not as bad as it looks. So negative 1 over 1 plus argument squared. Careful, make sure we square all the right pieces there. And then because we are chain rule experts, we won't forget to put a 4x up there. Okay, I'm going to stamp this problem before I even get started on it. Alright, the calculus is over. Now I just have to plug in 1/2 and keep everything straight. So negative 4 times 1/2 is 2. And in the bottom, 1 plus, what do I want to do first? Maybe that's the way to go. And then plug in the 1/2. Right? So I'm squaring the 2x squared, and then I'm going to plug in the 1/2. I don't know if that's the wise choice or not. Okay, 2 to the 4th is 16. Yeah, because 2 cubed is 8, so 2 times 2 times 2 times 2 is 16. 4 over 16 is 1/4. 1 plus 1/4, so 4/4 plus 1/4 is 5/4. And then keep it, change it, flip it. Negative 8/5, and there's my answer choice. A little bit of calculus, a whole lot of algebra. Alright, you reach the end of this video. You know there's 2 others that have the other thirds of the review worksheet.